In this video, we'll continue our discussion of section 14.8, the Jacobian. We're going to put this into practice now. So notice we have this integral. They gave us the region here. Now let's take a look at the region to understand why we need the Jacobian. Notice this is a slanted line, right? It has a slope of -2, intercept of 0. This is another line that's at a slant, not straight up and down. Same thing for here, and same thing for here. We have 4 lines, so it's going to look something like this. Something like that. So we're dealing with some region in the inside there. Now, the problem is it's all crooked and it doesn't make a nice easy bounds go from this x to this x, and then we'd have to start dealing with these weird like top slope minus bottom slope, and then at a certain point it's not even a straight up and down, it could be changed, and we'd have like 3 or 4 different types of integrals. So the Jacobian, what that's going to allow us to do is to create a new u and v. That way our u's and v's are nice and pretty. Okay, I gave a transformation here that wasn't given on the notes. These are going to be given to you most of the time. I may have you come up with your own, and in some of the problems in our homework, and that's free game on the test, but most of the time you will be given a transformation. What you do, so if given transformation, plug x equals and y equals into R. All right, so I'm going to do the first equation first. Y equals -2x. I try to stay we have quite a bit of work here, and try to stay as organized as possible. Okay, so I'm going to take y equals -2x, and I'm going to plug that in to plug the transformations in. So y equals v minus 2u equals -2 times x, which is u plus 2v. And what we do is work this out, and you'll see what happens. So I got v minus 2u equals -2u minus 4v. Notice that there's a -2u on both sides, so I can just make them go away. This gets me 5v equals 0, which tells me v equals 0. Okay, so I'm going to highlight that because I'll probably use it. All right, let's do the next one. That's going to be y equals, what was it? We'll do 1/2 x minus 15 over 2. All right, we're going to plug each part into that. So y is v minus 2u equals 1/2 times u plus 2v minus 15 over 2. Okay, so I get v minus 2u equals 1/2 u plus v minus 15 over 2. I'm going to multiply everything by 2 to make our lives easier. 2v minus 4u equals u plus 2v minus 15. Notice 2v's on both sides. Those are gone. So I get -5u if I minus u over equals -15, which tells me u is 3. I'm going to highlight that because I'll probably use it. Okay, I got 2 more conversions to do. Okay, I have y equals -2x plus 10. So we get v minus 2u equals -2 times u plus 2v plus 10. All right, I start working this out. V minus 2u equals -2u, -4v plus 10. Those go away. I add 5 over, I get 6v equals 10. 5v, if I could add right. 5v equals 10, which v equals 2. Okay, so v equals 2. I'm going to keep that one. I got one more here. I'm going to add a page. Sorry for you guys sticking close to notes here. All right, the last one is y equals 1/2 x. Okay, so we get v minus 2u equals 1/2 u plus 2v. Remember, we're just plugging those x's and y's into this equation here. That's all we're doing. By those x and y's, I mean these given here. I'm just plugging into the equation that I write down. All right, I got v minus 2u equals 1/2 u plus v. I'm going to multiply everything by 2. Just gets rid of the fraction. There are 2 v's on both sides. I get u equals 0 in this case. Okay, so we have those bounds, and what's really nice about these is that this integral that we were doing over R, the integral was x plus y dA, can now become the integral and we have u's and v's now. All right, u equals, and we have these bounds now. 0 equals, and I go back. The other bound for 0 was 3. So now that's nice, pretty bound, 0 to 3. Then I got v equals 0 to v equals 2. No more crazy bounds like the lines would have had craziness. Now I just take x plus y, and I go ahead and I'm going to write these again. What was it? X equals u plus 2v, y equals v minus 2u. And I just plug those in for each one. U plus 2v plus v minus 2u. Now this is, the Jacobian has to go here. And then we get du, dv, make sure they match the bounds. Okay, so we have to find a Jacobian. We want to rewrite it anyway. V equals 0, v equals 2, u equals 0, u equals 3. And then I can combine like terms in there. Okay, I got 3v minus u. All right, I got to find that Jacobian now. Okay, Jacobian says to take partial of x with respect to u, partial of x with respect to v, partial of y with respect to u, partial of y with respect to v, and find the determinant. Okay, so I have x and y right up there. I'm going to zoom out so I can see it. All right, so the partial of x with respect to u is 1. Partial of x with respect to v is 2. Partial of y with respect to u is negative 2. Partial with y with respect to v is 1. If I do this, I get 1 minus negative 4, which means my Jacobian is a nice pretty 5. Times du dv. There is my complete setup. All right, you can multiply 5 through to get that. I'm just going to give you the answer for this to keep it short. You don't need to watch me do integrals. I believe that you can do that. So if you do the integral for this, you get 45. I would check that to make sure that you line up to the same. So that is a Jacobian. Remember, it's just a three-dimensional u sub. It makes it legal by adding that Jacobian in.